SE203 Exercise Physiology Adaptations to Resistance Training. Resistance training is a form of exercise that involves using resistance to induce muscular contraction. The resistance can come from various sources, such as free weights like dumbbells and barbells, weight machines, resistance bands, or even the individual's body weight. Resistance modalities. Free weights, dumbbells and barbells are classic free weights that provide resistance through gravitational forces. They allow for a wide range of exercises targeting different muscle groups. Weight machines, fixed or adjustable machines designed to isolate specific muscle groups. They typically use a system of pulleys and cables and stacked weights. Resistance bands are elastic bands of varying resistance. They provide a portable and versatile form of resistance. They are often used for both upper and lower body exercises. Exercises like push-ups, squats, and lunges use the individual's own body weight as resistance. These exercises are efficient for building strength and endurance. Isometric training involves static contractions where the muscle length remains unchanged, like holding a plank position. Isotonic training focuses on dynamic contractions, with the muscle changing length during the movement. This includes concentric muscle shortening and eccentric muscle lengthening phases. Isokinetic training involves constant speed, typically using specialized equipment that provides resistance throughout the entire range of motion. Resistance training ranges/loads. Muscle endurance training is looking for 2 to 3 sets of repetitions between 12 and 20 plus. Hypertrophy training is looking to have 3 to 5 sets of repetitions ranging 6 to 12. Strength training sets 3 to 6 and repetitions 1 to 6. Power training 3 to 6 sets with explosive movements of 1 to 6 reps. Adaptations to resistance training. Muscular hypertrophy, an increase in muscle fiber size. Resistance training stimulates muscle protein synthesis, leading to the enlargement of muscle fibers, primarily through the addition of myofibrils and increased cross-sectional area. Neuromuscular adaptations, changes in the nervous system's control and regulation of muscle function. Improved motor unit recruitment, increased firing frequency, and enhanced neural drive contribute to greater force production and coordination during resistance exercise. Muscular strength, the maximal force of a muscle or group can generate. Resistance training induces structural changes at the cellular level, such as increase in the number and size of myofibrils, leading to greater force production. More changes. Muscular endurance, the ability of muscles to sustain repeated contractions over time. Increased resistance training volume stimulates mitochondrial biogenesis, improving the muscle's oxidative capacity and delaying the onset of fatigue. Connective tissue adaptations, enhanced structural integrity of tendons and ligaments. Resistance training increases collagen synthesis and the density of connective tissue, improving the tensile strength of tendons and ligaments. Bone density, the mass and mineral content of bone tissue. Weight-bearing resistance exercises stimulate bone remodeling, increasing bone density and reducing the risk of osteoporosis. Metabolic adaptations, changes in energy metabolism and substrate utilization. Resistance training elevates post-exercise oxygen consumption, contributing to increased energy expenditure and promoting fat oxidation. Hormonal responses, changes in hormonal concentrations in response to resistance exercises. Resistance training induces acute increases in hormones such as testosterone, growth hormone, and insulin-like growth factor 1, IGF-1, which play roles in muscle growth and repair. Flexibility and joint range of motion, the ability to move joints through their full range of motion. Resistance training that incorporates dynamic movements promotes joint flexibility by improving muscle and connective tissue extensibility. Cardiovascular health, improvements in cardiovascular function. Circuit-style resistance training with minimal rest intervals can elicit cardiovascular benefits, including improved heart rate variability and blood pressure regulation. Body composition, changes in the proportion of lean mass to fat mass. Resistance training, especially when combined with a balanced diet, contributes to increased lean muscle mass and decreased body fat percentage.